Geotechnical investigation is the first and foremost thing during the construction process of a building. In this process, the soil is taken from the ground surface in order to assess the various engineering properties. I am here to present a case study on one of the geotechnical investigations carried out. Let's go to the video.
Multiple types of geotechnical investigations were performed at each of the 3 sites associated with the TRC 1204 project. These sites being the Siloam Springs site, the Turrell site, and the Monticello site. For the purpose of this video, and for the purposes of the TRC 1204 project, these investigations are referred to as the Arkansas State Highway and Transportation Department, AHTD method, the Missouri Department of Transportation, MoDOT method, and the University of Arkansas, U of A method. As shown in these pictures from the Turrell, Arkansas site, the MoDOT method utilized a cone penetration test rig, CPT, while the AHTD and U of A method utilized a drill rig. The U of A method also utilized a trailer-based soils laboratory. 2 different drill rigs were utilized for the TRC 1204 project. A track-mounted rig was utilized at the Siloam Springs site, while an ATV rig was utilized at the Turrell and Monticello sites. The track-mounted rig is commonly utilized at sites where rock will be encountered. As shown in this photo, the data collected from these various investigation methods were within close proximity. The HTD Materials Division typically completes geotechnical investigations in all soils by conducting standard penetration testing, SPT, using a 30 mm split spoon sampler to obtain blow count values at the depths of interest. For the TRC 1204 project, the sampler was advanced 18 inches through all soil types at 5-foot intervals by using a 150-pound automatic trip hammer that was dropped from a height of 18 inches. The efficiency factors for the hammers on the HTD all-terrain drill rig and on the HTD track rig that were utilized for this project were 1.28. These efficiency factor values were obtained from previous pile driving analyzer (PDA) tests that were performed on an instrumented sampler and rod system that is owned by the AHTD. Other corrections that were applied included barrel, borehole, rod length, and overburden corrections to determine the correct blow count values. As discussed in the next video on geotechnical design using the FBD program, these corrected blow count values were either directly input into the design software programs or were correlated with engineering design parameters prior to the ingestion into the software programs. Correlated parameters that were obtained included the total unit weight, cohesion, friction angle, and relative density. For the AHTD method, these values were obtained from the table that was originally presented in the Bowles 1977 textbook. Additional information about various drilling and sampling procedures can be found in the video that was developed by Jason DeYoung and Ross Boulanger. This video can be obtained from the web address that is shown in this slide. As shown in this sped-up video, the HTD drill rig was utilized for drilling and sampling of the U of A boreholes. For the U of A method, the drill string pipes that are being tripped into the hole for sampling were 2 5/8 inch outside diameter NWJ drilling rods instead of the 1 3/4 inch outside diameter AWJ sampling rod that is typically used by AHTD. These rods were utilized because a 60 mm split spoon sampler was utilized for the U of A method instead of the 30 mm split spoon sampler that was utilized for the HTD method. The hammer was placed on top of the sampler string to drive the sampler into the ground, and the pipe was marked at 6-inch intervals. After the sampler was advanced 18 inches, or until refusal, the sampler string and sampler were removed from the borehole. The sampler was removed from the sampler string. The sampler was opened. The amount of recovered sample was measured and recorded, and then a representative 6-inch sample was selected. All of the material surrounding the 6-inch sample was saved into a plastic bag to be used later for laboratory tests. Moisture content tests were performed within the field on the laboratory sample from this surrounding sample. The marked 6-inch sample was saved into a plastic bag where it was weighed within the field laboratory to determine the unit weight, because the inside diameter of the sampler was known. Depending upon the types of soils encountered, the U of A method consisted of different techniques. When clayey soils were encountered, Shelby tube samples were obtained using either an Osterberg fixed piston sampler or a pitcher barrel sampler. As shown in this video, that was obtained while the Osterberg sampler was at the surface for demonstration purposes. The Osterberg sampler works by advancing the Shelby tube by using pressure within the drill string. For stiff soils, the pitcher barrel cuts the soil on the outside of the Shelby tube while the Shelby tube is advanced. After the Shelby tube samples were obtained, the Shelby tube samples were taken to the field laboratory trailer where a pocket penetrometer test and a torr vane test were each performed on the soil within the end of the Shelby tube. The Shelby tube was then loaded upside down into the miniature vane apparatus, and a miniature vane test was conducted on the soil. Following the miniature vane test, an 8-inch long section of the Shelby tube was cut from the bottom of the Shelby tube. Due to the concurrent drilling operations, these 8-inch long sections were cut when time allowed, and the sections were then stored for later UU testing within the field laboratory. Packers were placed within the top and bottom of the remainder of the Shelby tube, approximately 22 inches long, and that tube was then waxed. To ensure proper coating of the bottom, a 1-inch long water content sample was obtained from the end of the tube to allow room for the packer and the wax. When time allowed, the 8-inch long Shelby tubes were ripped along the longitudinal axis using an end grinder and Dremel tool. A coping saw was then placed through the open cut and was circumferentially rotated around the inside diameter of the tube to break the bond between the sample and the Shelby tube. The obtained sample was then cut to a 6-inch length using the cutting jig. The diameter, length, and weight of each sample were recorded for unit weight determination. Each sample was then tested in the UU device. A membrane expander was utilized to place a membrane around the sample. Then the sample was placed in the triaxial cell and loaded to failure using the load frame. Cell pressure was applied during the UU test by using a pressure pump.
The MoDOT CPT method consisted of utilizing the track-mounted CPT rig to push a 10 square centimeter, 60-degree cone into the alluvial, deltaic, or weathered soil deposits that were encountered at the Turl, Monticello, and Siloam Spring sites, respectively. To achieve the 10-ton capacity, the helical reaction anchors that were attached to the CPT rig were screwed into the soil. The hydraulic leveling plates were then lowered to the ground surface, and the strike plates that were used for the shear wave propagation were placed underneath these leveling plates. The downward force on the strike plates ensured coupling between the soil and the plate for proper shear wave propagation. The instrumented hammer shown in this photograph was used to strike the strike plate. When the hammer struck the plate, the metal-on-metal contact closed the circuit and the time for the strike was recorded. The plate was struck from both the A and B sides to induce opposite polarizations that assisted with determining the arrival of the generated shear waves at the sensor. The cone tip was equipped with the following direct measurement sensors: tip resistance, sleeve friction, excess pore water pressure, tilt, and seismic velocity. Prior to mounting the cone tip into the CPT rig, the pore water pressure sensor was saturated and a membrane was placed over the sensor to ensure saturation during mounting. As shown in this sped-up video, the cone was pushed in 1 meter increments, but data were collected and returned every 0.1 meters, with the exception of the seismic velocity data. The seismic velocity data were collected every 1 meter, while the next 1 meter long joint of CPT rod was added to the CPT string. As previously mentioned, the plate was struck from both sides to generate the polarized shear waves. All of the recorded data were then converted to engineering parameters through the use of correlations. The correlations were obtained from the Robertson and Cabal CPT manual.
In this video, we came to know about the various processes and steps involved in carrying out a geotechnical investigation. Thank you.